Go. Hello everybody. I'm not sure if I'm now on air, if everything is set. Welcome to our webinar. I'm very glad that you all are here today. And I would like to welcome you not only on behalf of myself and Industrial Solar, but also on behalf of GIZ and on behalf of the project Solar y Vapor, funded by the German Ministry for Education Research and the Mexican CONACYT. So before we start actually to talk about energy solutions for industry, I would like to make some remarks on renewables and on the history of energy and industry. On this slide here, you see the Seattle around the turn of the last century, around 1906, and you see a lot of smoking chimneys. And even nowadays, the symbol for successful industry are smoking chimneys. And we think it's about time to change that. Even though not too much has changed yet. On this slide, you see an industrial zone in the US in the year 2010, and it's also full of smoking chimneys. And yeah, it shows that we are emitting a lot of emissions, carbon emissions and other emissions, mainly from fossil fuels. And on this slide, you can see the development of our total carbon emissions from fossil fuels from 1800 until now. And you see it was a tremendous growth, and you all know the problems that this is causing. A lot of people think that renewable energies are expensive. They're more expensive than fossil fuel. This depends on one hand side what costs you take into account, internal costs or external costs. But actually this perception is also falsified by very high subsidies which are given by the governments of many countries to companies producing fossil fuel. And International Monetary Fund made a study, and they came up with an amazing number, which is $5.3 trillion a year is spent for subsidies globally for fossil fuel. And this is actually equivalent to about 10 millions per minute. So you might understand now why fossil fuels are said to be cheaper than renewables. Actually, without subsidies, renewables would be cheaper from now. So let's come to the point. We are now here today to talk about sustainable energy solutions for industry, from energy monitoring to energy efficiency to renewable energy technologies. I'm actually one of the founders and one of the managing directors of Industrial Solar. Industrial Solar is a company that was created in the environment of Fraunhofer ISE. We are based in Freiburg, in Germany, in the Black Forest. And we offer sustainable energy solutions for industry. We offer as well consulting for companies as for policymakers, and the solutions that we offer for industry, there we basically start from early consulting services over engineering, installation and maintenance. Our technologies that we offer to our industrial customers, this portfolio has developed over time. Our flagship product is the so-called Fresnel collector. It is a linear concentrating solar thermal collector that can generate temperatures up to 400 degrees C in the megawatt range. But as we have talked with many potential customers in the past, we understood that this technology is one solution for some of those companies, and we realized that we need a broad technology portfolio to come up with the most financially viable and technically sound solution for each customer. So we have broadened this portfolio. We integrated all types of thermal technologies. We have PV, heat pumps, cogeneration systems. So you name it, we have it. Coming to the potential. Industry is responsible for almost 1/3, to be precise, 27% here in this graph, of the total energy consumption, total final energy demand, actually. And it's very interesting to see that industry needs about twice as much thermal energy than electric energy. This is also not commonly known. Most of the people, when they start talking about energy, they talk about electricity. But only few people are aware that industry needs about twice as much thermal energy than electric energy. And if you take an even closer look at the data of industry, then you see that more than 50% of this thermal energy demand are in a temperature range below 400 degrees C. And this is a temperature range that can be supplied with solar thermal technologies, with linear concentrating solar technologies. There are even other solar technologies like point focusing systems that can generate higher temperatures up to 1000 degrees C or above. But for the time being, or as a first step, I see non-concentrating and linear concentrating technologies in industry to supply energy to industry. So now it's time for our first block of questions. So please answer these questions. And as far as I understand, you got like 45 seconds and then we come back. If you don't answer, we won't continue. So please go. Okay, I think time is over now. Let's go back to the presentation. I hope you all answered the questions. And now we continue with the solar potential in Mexico. You Mexicans are really lucky because you live at a sunny place. We in Germany, we are not that lucky. It's a bit more rainy here, a bit more dark. But here you see the map of Mexico, and the color gives the yearly sum of the direct normal irradiation. And the direct normal irradiation is the part of the solar radiation that can be concentrated with concentrating solar collectors. And you see the blue parts are not that good. The yellow ones are quite good already, like Spain more or less, and the red ones are excellent. So if you are placed in one of these red zones here on the map, you will know what we talk about. It's very, very sunny, and solar energy technologies make perfect sense in this region. So on this slide, we made a couple of simulations for different places in Mexico, like Puebla, Culiacán, Guadalajara, Monterrey, and Hermosillo. And the yellow bars show the yearly sum of the direct normal irradiation. The blue bars show the gross heat production, and the purple dot shows the mean yearly efficiency. These calculations were made for our linear concentrating Fresnel collector. And you see that the mean yearly efficiencies are all around 40 or above 40%, which is excellent. Here in Germany, we would have less than 30%. In Spain, between 30 and 40, but in Mexico, you are mainly above 40. So the message is, it's a very good place for such technologies. Here you see a graph made by the International Energy Agency. It's a prediction of the future market for solar thermal technologies. The bright blue part is solar water heating. The darker one is solar space heating, and the green is solar industrial process heat. They call it low temperature. Actually, they're referring to temperatures below 250. There is a little confusion with the convention in terms of temperatures. So below 250 is low temperature for process engineers, and for solar people, it's definitely no low temperature, it's medium temperature. But you see that this market is going to grow substantially in the next years. Solar space heating, we also have solar swimming pool heating, also interesting market, but I don't think you need a lot of pool heating in Mexico. Sectors, some examples of companies or branches that need heat for their production lines. I guess there are some of you now listening to this webinar, and you'll find yourself on this list. Like dairies need a lot of heat for pressurization, sterilization, pasteurization, and so on. Tin food, pharmaceutical companies. We just made this project in Jordan, which I will present a little bit later in this presentation for a pharmaceutical company. Textile companies need a lot of heat for dyeing of textiles. Paper companies, chemical, and so on. Meat, also very important. Meat and beverage, like steaks and beer, but also plastics, automotive, metal, and tobacco. But we could continue this list and add many more branches. So if you don't find yourself on this list, don't worry. We know there's much more out there. So we're coming now to the second block of questions. Please answer the questions that I will show you now. You should see it by now, I hope. Okay. I think most of you have answered the questions now. So let's go back to the slides. So on the next slide, it's a graph that's actually showing the situation in the US. Just an example. Here you see the energy input on the left-hand side, in the middle the US economy, and the right-hand side the outputs. And the numbers are quite amazing. You have like 85% non-renewable fossil fuel input, and a couple of percent of other power, non-renewable nuclear, hydropower, geothermal, wind, solar, and so on, biomass. And what you get as output is 9% of useful energy, 7% of petrochemicals, and then comes a huge block with 41% unavoidable energy waste. And then comes an interesting block for us, is unnecessary energy waste. So 43% is unnecessary energy waste. And this is actually something we should work on together. This will save you money and will do good to the environment. So our approach is, when we meet an industrial customer, we start with an energy monitoring. We gather the data that the customer has. If the customer doesn't have a good energy monitoring system in place, we can install an energy monitoring system. Based on this data, we then do an energy analysis. And of course, we try to harvest first the low-hanging fruits, which is energy savings or energy conservation. In the next step, we then do improve energy efficiency. And last but not least, we integrate renewable energy technologies. And now talking about renewable energy technologies, here we have a couple of solar thermal technologies and comparing them in terms of working temperatures. So if you need just the pool heating, then you can use unglazed collectors. They're very cheap, very simple, very robust, very easy to install. In Germany, they have payback times of typically less than a year. I guess it would be similar in your latitudes, even though I think you don't need so much pool heating there. But maybe I'm wrong. The next level would be flat plate collectors. These are the typical collectors that are used for the domestic hot water systems. They're performing very well in the temperature range up to 60, 70 degrees C. If you need higher temperatures or if you have lower ambient temperatures, then you could also go for vacuum tube collectors, or also even flat plate or evacuated flat plate collectors, which is kind of a new technology. And with those you can reach temperatures above 100 degrees C, up to 120, 130, even a bit higher, but I think the sweet spot of this technology is somewhere around 100 degrees C, a bit more. And then in the top level we have the linear concentrating collectors, which are uniaxially tracked. Here you see on the right-hand side the parabolic trough collector, and on the left-hand side the linear Fresnel collector. Both technologies can reach temperatures well above the 130, and the maximum temperature they can actually reach depends not only on the concentration ratio but also on the thermal insulation of the absorber tube. If you use a vacuum receiver in a linear concentrating collector with such a concentration ratio like our Fresnel collector around 80, you can reach temperatures around 400 degrees C. Basically there we have the limit of the receiver tube, which is limited to 400 degrees C. Now for power plants, there are even systems out there that can reach temperatures up to 550 degrees C with molten salt, but this is not like a technology that is in the focus for industrial applications. We have made a little survey in the past, customers that had contacted us with steam systems, and we realized that like 80% of the requests were in a temperature range between 130 and 240, 250 degrees C. So this is why we see actually linear concentrating collectors as a very important technology for industrial application, because the typical non-concentrating thermal collectors, they are good for generating temperatures below 100 degrees C, and this is a temperature range where industry very often has waste heat. Yeah, coming to feasibility, when we analyze the situation at industrial customer, of course, we have to take a lot of things into account. Sorry. We have tried to visualize this on this slide. Of course, we have to see what is the temperatures or what is the supply temperature that the customer needs for his thermal process, what collector technology we can use for this temperature, how much space or area does the customer have, what's the budget, load profile, and so on. And taking all this into account, we are trying to find the most economic solution. Talking about economics, this is a screenshot from our economic analysis Excel file, which has become rather complex meanwhile, but I just want to give you an idea what we are looking at here or what numbers we are analyzing. So we basically define the solar system that you would install at your site and make a financial analysis. So we estimate the investment necessary. We see what's the current cost of energy. We make an extrapolation of the cost of energy in the future. And we take into account the parameters of financing, like interest rate and so on. And then we can calculate parameters like the net present value, internal rate of return over 10 years or 20 years, payback time, and so on. And we generate some graphs showing you the cumulated cash flow over time. And so we're trying to give you a very clear analysis of the financial situation with such a system. Yeah, as I said before, we're trying to harvest first the low-hanging fruits. Of course, like if a customer is heating with electricity, we have met companies that generate steam with electric steam generators. There, it's typically economically very attractive to replace or to combine such electric steam generators with solar technology. Diesel is also very expensive, and if you have natural gas, then you are rather well positioned because this is rather inexpensive. So we are trying to find customers that are using a rather expensive energy like electricity or fossil fuel. Okay. Yeah, also very important for thermal technologies is that operation is continuous over the full year, like 365 days, 24 hours, continuous demand. So we have to check your load profiles. Low temperatures are less expensive, so that solar technologies providing low temperatures are more simple and more inexpensive. Large systems are also more attractive, so the specific costs in large systems are lower, of course. You have the economy of scale. And also if you have a company building with a concrete roof, it's usually much easier to install something on the rooftop than on very weak roof structures with corrugated sheet metal. And if you are placed in a location with high irradiation, then the installation will provide more energy to your company. Yeah, the challenges are low energy costs, like we have now currently. The world market price of oil is extremely low. We just can hope that it will go up again. High investment cost is always an issue with renewable energies. You have to buy the system and it will basically provide you energy for the future. So financing is very important for renewable energy technologies. We have to raise the awareness. This is something we are here now all together today. And the There's also some issues like missing solar heat for industrial processes, specific solution, that there are not enough companies providing solutions. There are not enough pilot projects maybe, or not enough supporting policies in place. Some examples of solar process heat systems with different technologies. This is actually an example from Austria. It's a flat plate collector field with more than 1,000 square meters aperture area that is providing process heat to a meat factory in Austria producing ham. Next example is example from the colleagues of XL. It's a vacuum tube system in Switzerland. I think that's the company Zehnder. They're producing heat exchangers like for space heating. And it's an evacuated tube collector field with about 405 square meters aperture area, providing process heat at 95 degrees C, which is mainly used for a galvanizing process. A project from ourselves here is a air collector system installed at the pharmaceutical company, actually at Pfizer. It has a aperture area of 130 square meters and is providing hot air, which is used to regenerate a sorption wheel that is used again for a drying process. And last but not least, a project with our Fresnel collector that we realized at the pharmaceutical company in Jordan. This collector is providing steam. We do have a technology called root storage, so we have a short time buffer storage for steam. The collector field is generating a two-phase flow, a mixture of water and steam, which goes to the steam drum, which is there separated, and the steam drum actually acts also as a buffer. So if there is a cloud going over the collector, we still have 50 minutes buffer time, and there is still the fossil-fired steam boiler. And the system is performing very well, and we are currently working on some leads in Jordan. Yeah, some further aspects. What is important when we talk with industry? What is the demand? What can you supply? What solutions are available? What technologies are viable in terms of risk and cost? This directly goes to feasibility, financial feasibility, economics, and as mentioned before, financing seems to be the key to the introduction of solar technologies to industry, because no industry can finance such a system out of the working capital, so you need a loan. And we are, as a solution provider, try to help you get this loan from a development bank or some other institution, or even commercially. We have financial partners that can offer you contracting solutions, meaning they do the investment and you pay for the energy. So you have to sign a power purchase agreement, a PPA, for so and so many years, and then the financial partner will do the investment. And of course, we try to maximize local value, because it doesn't make sense to ship material from Germany to all over the world. So we have recently won a prize in Germany, the innovation prize for environment and climate, and we won in the category technology transfer, because we have shown with our projects like in South Africa and the one in Jordan that we can reach a very high local value, that we do the installation and assembly with local people, and yeah, so that we are not trying to sell solutions made in Germany to the rest of the world, but that we are taking the solutions to the countries where we have the problems and where we have to sell. So now comes the third block of questions. Please go ahead, and I will switch on the survey. You should now see the questions. Please answer. Okay, I think you've answered. So let's go back to the slides. I think we're almost done. Yes, basically we're jumping over one slide here. Summarizing everything, there's a great potential for solar heat industrial processes, abbreviated SHIP. The relationship between SHIP and the solar thermal market, it's a complex market. It's not easy to introduce this technology to industry. We have to raise the awareness. We have to basically realize this huge market potential, and we are optimistic that we can do this with partners like GIZ in Mexico and other countries, and we are very glad that we have the support within our Solar Vapor project that is subsidized from Germany and Mexico, CONACYT, and I think this will bring us forward, and I'm looking forward to more webinars, and I'm looking forward to more or the first installations now in Mexico for industry. Thank you very much. We are not finished yet, so now we come to the great contest. Get ready for the smartphone contest. So I hope you're ready. Let's go. Here comes the final ultimate question. What solar collector technology can reach higher temperatures? Is it a flat plate collector or a Fresnel collector? And now you should have some area under the image of your speaker where you can write the answer. And to type the right answer, we'll get a smartphone. So, nobody. I'm waiting for the name to appear in my chat window here. No one has answered. Come on. Simple question. Some more time. So either flat plate collector or Fresnel collector. The Fresnel collector is the one which is concentrating. So I read that we got a winner. And his name is Manuel Gonzalez. Congratulations. Okay, so have fun with your smartphone. And thank you for attending our webinar. And please don't hesitate to contact us if you have any questions. Here I see some questions. I think to answer a couple of questions. I think the first question here I see is, no, it's not question, it's basically the people who answered the contest for the smartphone. So I don't see any questions here. So thank you. And if you should have any question, please send us an email or contact us and stay in touch. Have a nice day. Bye-bye.